Hi. Before starting this course, data skills to me registered somewhat as a set of tools to learn and apply. That framing, I think, came from limited exposure, well-defined tasks where the anticipated outcome was already clear. In education, for example, where you have a working relationship with your pupils, you likely have a better grasp of their abilities than what summative data collection will try to tell you. Anyway, I'm almost sure the work covered over the course of this data skills bootcamp expanded my understanding of datasets far beyond that. From there, my attention may have gradually shifted towards how different kinds of data behave once they become less tidy. Some tasks, for example, encouraged looking beyond the immediate output, which meant spending more time with structure, scope, and context, because choices made upstream tend to limit or enable what questions can sensibly be asked later in the process. Over time, my attention honed into a smaller number of projects, focusing on what could be learned by adjusting assumptions, adding checks, or pushing the data further than the brief required. Data relationships might beg additional questions of an analyst to the visualization stage, and that can be a very good thing because it allows weak assumptions to surface earlier, before they become embedded in charts or summaries. This type of approach, I think, shaped which projects stood out to me and which ones became more substantial pieces of work by the end of the course. With that context in mind, we'll cover a small number of projects that I think might carry some weight because of what they allowed me to explore and learn. To start off, one of my earlier projects involved producing and analysing revenue data for a subscription service with various pricing rules and tiers. What made this project worth spending more time on? The dataset produced was custom made and designed to tell a particular story through predetermined trends. When it came to building visualizations, that made it easier to see how a narrative translated into the chart form, and to recognize similar patterns more confidently later on. That process drew attention to how structure in the data carries through into structure in the visuals, because the same number can appear quite differently depending on what gets grouped, compared, or emphasized. Time spent on visuals in this project connected to noticing how small structural changes could alter how confidently certain trends appeared to hold up, because inconsistently framed metrics can exaggerate or flatten patterns without changing the underlying values. A useful question that came out of this was, what influences how someone reads a dashboard before they start interpreting the numbers? One conclusion that might be drawn is that elements such as hierarchy, spacing, and consistency tends to guide how a dashboard gets read before the detail is engaged with. Designing data with an intended trend in mind also seemed useful beyond this project, because being able to recognize a known pattern made it easier to judge whether a visualization behaved as expected. Some of the Python work during the bootcamp particularly appealed to me, especially tasks where the brief involved loading a dataset through code, curating it, and then producing visual output programmatically, with the option to select an additional dataset if time allowed. Those extra datasets covered a range of areas, including financial data, jobs and employment, business, education, and government sources. Rather than picking one arbitrarily, curiosity centered on how choice could be made more deliberately. What might it look like to compare datasets before committing to analysing any of them in depth? To explore that, code was used to inspect and compare the datasets on characteristics such as size, variation, and structure. The aim was to identify in simple terms the most information-dense or juiciest dataset to work with. Based on those comparisons, a dataset labelled London Airbnb stood out due to its volume and range of available metrics. From there, the expected process was followed, the dataset was mounted, and a set of visualizations was created. Some curiosity remained after that stage, particularly around whether insights could be generated without relying directly on charts, which led to experimenting with code that surfaced structured, fill-in-the-gap style analytical outputs. That tangent felt useful beyond the task itself because it shifted attention earlier in the workflow toward dataset selection and validation, and it highlighted how code can support cleaning, visualization, and interrogation at scale within the same process. Later in the course, attention turned toward working with geographic data with the aim of building a heat map. That started with a specific idea, UK broadband speeds by code. It sounded promising, but once the data was examined more closely, it didn't support the scope I had in mind, either in coverage or in how consistently it could be mapped. After some searching, I came across UK road fuel data covering 2020 to 2024, provided as a set of CSV files. Using Python, those files were curated and combined into a single data set so patterns could be explored across years rather than in isolation. From there, Tableau was used to start shaping a geographic visual. At that point, another constraint became clear. The data wasn't organised around postcodes or local authorities, but around ITL regions, which meant the relationships weren't a direct fit for the map I was trying to build. The next step involved sourcing an ITL2 shapefile and joining it correctly to the fuel data. Other levels were available, but ITL2 felt like a sensible balance, particularly with animation in mind and a desire not to overload the system. That process highlighted how different tools lend themselves to different kinds of work. Producing charts through Python can feel relatively intuitive once the data is prepared, while larger scale geographic visuals tend to introduce additional structural and performance constraints that are often easier to handle in specialist visualization tools such as Tableau. The largest piece of work I spent time on over the course was the OList data platform project, which focused on building a complete local data platform rather than analysing a single dataset in isolation. The work started by setting up a local containerized environment to act as the foundation for the platform. Raw OList CSV files were stored in Mini.io, which functioned as an object storage layer for unprocessed data. Apache Airflow was then introduced to manage how data moved through the system. This involved writing DAG files that defined task order, dependencies, and execution flow. These tasks handled actions such as pulling files from Mini.io, loading them into PostgreSQL, and ensuring each step completed before the next began. Getting those DAGs to run end to end took a significant amount of iteration. Task ordering had to be adjusted, connections configured correctly, and schema-related issues resolved as they appeared. It took well over a dozen revisions before data could move reliably from raw storage into PostgreSQL. Once those problems were worked out, though, creating DAGs for the remainder of the project became much quicker, as the same patterns could be reused with smaller changes. PostgreSQL acted as the central warehouse once ingestion was stable. From there, dbt was used to stage and clean the data, taking roughly half a dozen raw tables and reshaping them into a smaller set of curated analysis-ready dimension style tables. This step focused on consolidating fields, standardizing formats, and keeping a clear separation between raw and transformed data. But with the pipeline in place, the next step was to bring the curated tables into Power BI and model them there. A small number of proof of concept visuals were created at this stage, mainly to confirm that the data behaved as expected once it reached the reporting layer. With that experiment complete, the project was written up in a report outlining the process, intentions, and outcomes, rather than leaving the work distributed across configuration files and scripts. Services such as Azure, AWS, and GCP are widely used and effective, particularly for organizations operating at scale. For this project, building a locally hosted platform had value, as it allowed the entire pipeline to be explored end to end with no ongoing running costs beyond the hardware itself. The practical outcome is a reusable local data platform. The same ingestion patterns, DAG structures, and transformation logic can now be applied to larger data sets or more complex projects without rebuilding the pipeline from scratch. If there's one thing that carried through the course, it was the value of experimenting once the core task was complete. After meeting the brief, Any remaining time often went into pushing things further, testing ideas independently, or seeing what would happen if the scope was widened slightly. That approach led to questions that weren't explicitly set, and in several cases sparked entirely new lines of work. Working that way made the projects feel less like isolated exercises and more like opportunities to explore how data behaves under different assumptions, tools, and constraints, which is something I expect to keep doing beyond the course itself. Thank you.